The Doppler effect is something that you observe often. Think of sirens whenever you hear the change in noise of the siren as it's moving towards or away from you. That's the result of the Doppler effect. So what is it? All it is a change in frequency when a source moves relative to an observer, and you'll hear me using observer and detector interchangeably. The frequency increases when the source and detector get closer together, and it decreases when the source and detector get farther apart. So what's actually happening, remember, frequency is the number of cycles per second for a wave. So what's happening is as the source gets closer, the waves are kind of doing that, versus when it gets farther away, the waves are going to stretch out. But because they're moving at the same wave speed, it's frequency or period that would be changing. The equation for Doppler effect, I'll write what all of these are. FD equals Fs V plus Vd over V minus Vs. What are all of these? Let me circle this, or box it. This is the detected frequency. That looks really bad. Detected frequency, so in other words, this is what the person who is the observer or the detector hears. This is the source frequency. So this is the frequency that's actually being produced, and that's a constant. So in other words, this doesn't change because the frequency of the source isn't going to change. What does change is the detected frequency as the objects are moving relative to each other. Both of these V's, so this V and this V, are the same thing. Speed of sound. So that's where you want to use that 343 meters per second. This is the speed of the detector or observer. And this is the speed of the source. So it's a messy equation, but you'll notice that you're multiplying frequency by speeds over speeds. So all of these units end up canceling out, which is why you do end up with a frequency equaling a frequency, just multiplied by all of that. There are some sign conventions that you need to know. The speed of the detector is positive if it's moving toward the source, negative if it moves away, and it's the same thing for the source. So speed of the source is positive if it moves toward detector, negative if it moves away from the detector. So unlike anything else we've done all year where positive was right or up and negative was left or down, in this case with the Doppler effect, the sign conventions, and you just need to know this, it's positive. So in other words, these can be positive or negative. So positive if it's moving towards the other object, negative if it's moving away. This positive and this negative stay in the equation, but they could change when you actually do the math depending on what that and that are. I'll do two examples. If you're okay after the first one, then you don't need to watch the second one. But I'll do two examples just so that you can see how the Doppler effect works. Conceptually, what you are responsible for is knowing how the frequency changes as things move towards or away. So closer, frequency increases, farther, frequency decreases. So this reiterates what I just wrote on that last slide. So speed is negative if either source is moving away. Speed is positive if either source is moving, or either source or detector is moving towards. So this is exactly what I just wrote on the previous slide with the Vs and the Vd. A fire truck emits a siren that has a frequency of 330 hertz. It is traveling towards a stationary observer at 45 meters per second. What frequency does the observer hear? So we've got a fire truck. Here's the siren making noise, and it's moving. And then you have a stationary observer, so the person is at rest. Our given information, we know that the frequency of the source, so source equals sound. Source is where the sound comes from. So the frequency of the source is coming from the fire truck, is 330 hertz. It's traveling towards the stationary observer at 45 meters per second. So V of the source is 45 meters per second. It's positive because it's moving towards. The observer is at rest, so that's the detector. So VD is 0 meters per second, and we're looking for the detected frequency. So FD equals Fs V plus Vd over V minus Vs. In this case, our detector is at rest, so that goes to 0. FD equals 330 hertz times 343 meters per second over 343 meters per second minus 45 meters per second. And this will come out to 379.83, keeps on going, hertz. This number is higher than the source frequency. Again, if you're getting closer towards the source, then the frequency should be higher, so that makes sense. There are only 2 sig figs, so the detected frequency is about 380 hertz. I'm going to do one more example where we're solving for something other than frequency, just so you can see how that works out. If you don't care to see how to solve for one of the velocities, then stop watching. We'll just do practice in class tomorrow. If you do want to see, then it's just one more short example. Okay, during a prison break, a prisoner who was running away from the prison hears the siren blast with a frequency of 400 hertz. But the siren actually blasts at a frequency of 440 hertz. How fast is he running? So here we've got the prison. There's a siren sounding from the prison. And obviously the prison is at rest, it can't move. And then you have the prisoner who's running away. So our given information, the frequency of the source is 440 hertz. The frequency he detects is 400 hertz. And the velocity of the source, it's at rest, is 0 meters per second. And we're looking for how fast is he moving. Frequency detected equals frequency of the source, V plus Vd over V minus Vs. In this case, the Vs is 0, so that's a little bit easier since that goes away. And I'm going to isolate and solve for Vd. So FdV equals Fs V plus Vd. Just brought the V over to the other side. Let's isolate Vd. So FdV equals Fsv plus Fsvd. FdV minus Fsv over Fs equals Vd. Let's put the numbers in. I'm just going to go to the slide so I have room. So my FD, 400 hertz times 343 meters per second minus 440 hertz times 343 meters per second over 440 hertz equals VD. This comes out to negative 31.181, keeps on going, meters per second. It should come out to negative because the prisoner is running away. So because this is negative, it means he's moving away. So the math worked out to show us what that sign should be. We only have one sig fig, so VD is about negative 30 meters per second. So unlike what we've done before where positive or negative meant left or right, positive or negative just tell you how they're moving in relation to each other. So towards or away, it's the biggest thing you have to remember with Doppler effect.